At the free end is allow free to move and free to rotate. So that means, and there's no bending that's there to constrain such a motion. And there's no transverse loading, so M and V equal to 0. But because the free end is free to deflect, so that means we wouldn't impose any geometry-related boundary conditions. And the last one, 7. So here you can see here has the two pieces of the link or beam they paint together. So here they paint here, and that one is called the internal pin or hinge. So for this case, at the pin or hinge here, the two beams are free to rotate from each other. So that means the M equal to 0. And because this pin is freestanding, it didn't fix against the ground, and that at the pin here, it might be floating up and or down. So here we only impose is M. So from here you can see, let me change this one to top here. So here is a very complete the category of all the possible boundary conditions you might see in ESP31. And actually this is a very good information for you to maybe in the future for advanced topics. From here I want to highlight is this. For the first two information, those are the boundary conditions regarding the geometry. The bottom, the two, from here you can see that is a force related. Boundary conditions. And those one would have the further discussions in finite element. If you have been heard about the finite element, or in advanced mechanics material, we would have a further discussions on the two types of the constraint. But here you only take it. So basically in your learning, you just simply take two categories. And before today, before we start in this new second approach, for the first example, we only exercise is about the first type, geometrically related boundary conditions. Using this example, I want to exercise the second types as well. So from here you can see, in this way, the last two is regarding the geometry related. This one is regarding the force related boundary conditions. Okay, so from here we can pick up the more information. So we can see what we can do. So we look at this carefully. We look at this one. From here you can see the boundary conditions. And let me use this one. Let me use the green one. So at this end here, and which type we can see the case 5. So that means the deflection equal to 0 and slope equal to 0. Right? And at this end, we can utilize case 6. So that means bending equal to 0 and transverse loading equal to 0. So here we have 1, 2, 3, 4 boundary conditions, and will be identified. So here we simply write it down the appropriate equation for this one. So here at x equal to 0, the deflection equal to 0 and slope equal to 0. And that is the meaning of this one. Okay, so here this deflection equal to 0, that means we're using equation 4. So let me give the equation numbers. So this is equation number 1, 2, 3, and 4. So that means the using equation 4, we can obtain is C4 equal to 0. And y prime equal to 0, so that means here we're using equation 3. Okay, because you can see right now I simply identify the boundary conditions and then introduce the boundary conditions into appropriate the equations. This one regarding the slope, so I pick the slope, equation 3. So that means here I can solve for C3 equal to 0. Okay? And now we use this one. So at x equal to 3 and L, then you can see the boundary condition V equal to 0. So that means V equal to 0. M equal to 0, let me do this one first. So M equal to 0, so that means M equal to 0, what is M? M is bending. Bending moment is regarding this equation. So the bending is regarding y double prime. So that means y double prime at L over 4 equal to 0. So from here we can see C2 equal to 0. Okay? So right now we have the boundary conditions. Then there I show you is to introduce the appropriate equations. The last one is V. And what is V? V is about transverse loading. Then go to here. So that means y triple derivative at 3 and here equal to 0. So from here, this is Cy equal to 0. So for these simple examples, that is very straightforward. So from here, therefore, EI y of x simply is this term minus omega 0, 24 x to the 4th power. No. I made a mistake here. Do you know why? Right now we do this one. So this is through equation 2. So this is through equation 1. So let me do this calculation. So by introducing to equation 2, this is equation 2. So that means here the 0, and this one, let me modify here. Equation 2 is this one. So that would be 0 equal to minus omega squared q L squared plus C1 x plus C2. And this one is equation 1. So that means 0 equal to minus omega x L plus C1. So here, C1, C2 shouldn't be equal to 0. From solving for this one, C1 equal to omega L, and then C2 will be equal to how much? Let me copy my answer. Minus omega 0 q L squared. Sorry. So here we should have two more terms here. Plus 6 omega L x cubed minus omega L squared or x squared. Yeah, that should be the final answer. So if we will be able to draw these diffractions, so this is the given one. The diffraction should be like this. Ouch. So if we want to calculate how much is this one. So we can plug in EI. Y at L will be equal to 1 over EI. We simply introduce the L equal to that equation, X L force plus 6 omega L L3 minus omega L squared 4 L squared. So we simply do the integration, the calculation. This one will be equal to minus 8 EI omega squared L to the fourth power. So here, because we define our the coordinate system as x, y like this, so that means negative value is meaning the deflection, the vertical displacement is downward, and that means this at the free end, the deflection, the magnitude equal to omega squared force and divided by 8 EI. Again, here is meaning the magnitude, and here the negative, that means that is the moving downward. Okay. And in our appendix, we have summarized a few cases, and here I just print up, and this one is on the back side of your cheat sheet. So this one, the reason why I put onto the cheat sheet is for you to better utilize the information. After you exercise how to do this one, then you can utilize the information in the test. And here I just give this to you. And would you mind if you have more, you just pass over to that side?